In backend development, rate limiting is a strategy for controlling how many requests clients can make to an API endpoint within a given time window before being rejected. This strategy is essential for protecting your API from potential abuse or denial of service attacks, keeping the access to your backend's resources fairly distributed between clients, managing cost when implementing paid APIs, and overall improving the user experience by gracefully throttling your API rather than letting it crash when under too much pressure. So in today's tutorial, I will walk you through 3 classic rate limiting strategies called fixed window, sliding window, and token bucket that we'll implement one by one in the form of Node.js modules and that we will test using a minimal Express server instance. Guys, it's no secret. Learning backend development on your own is extremely hard. Before becoming a senior Node.js engineer with now over a decade of experience, I've also failed at it for years, and probably for the same reasons that you're struggling with it right now. So this is why I created the Learn Backend Mastery program, a program designed to remove all the guesswork and to take you from dabbler to job-ready Node.js backend developer in only 12 months. The program is centered around an interactive roadmap of 136 lessons spread across 11 branches like the CLI, Bash, JavaScript, Node, SQL, Express, and more, allowing you to always know what to learn, when to learn it, and in which order without confusion. Each lesson is crafted to teach one specific concept in a beginner-friendly and straight-to-the-point way, and is illustrated with code snippets you'll actually use in real projects. And because only practice makes ready, the Mastery program includes 25 hands-on projects with step-by-step commented solutions you can study, including command line tools, system simulators, games with simple AI, online services, and more that will truly challenge you and help you build a bulletproof problem-solving mindset. So if you want to get serious with backend development and make real progress fast, check out the Mastery program at learnbackend.dev/getstarted. Link in the description below. And without being said, let's build. The fixed window strategy consists in dividing time into fixed slots, for example of 1 minute each, and counting how many requests a client makes within the slot. Once the client exceeds a predetermined maximum amount of requests per slot, all further requests are blocked until the slot resets. It's important to note that while this strategy is quite simple to implement and uses minimal amount of memory, it could easily lead to potential spikes at window boundaries, as a client could, for example, send 10 requests at 12 and 59 seconds and another 10 at 12:01, effectively making 20 requests in 2 seconds. This is why this strategy is often used for internal endpoints rather than public ones. Now that we conceptually understand how it works, let's translate that logic into a small Express middleware. So within a file named fixedwindow.js, let's define a new function named fixedWindow that takes as parameters the maximum amount of requests a client can make, the duration in milliseconds of the time slot, and returns an Express middleware function. Once we've done that, let's right away export this function as a Node module so that we can later import it into a minimalistic Express server for testing. Let's now use the map object to create an in-memory store for tracking the number of requests made by clients within each time slot, where each key will be the client's IP address and each value will be an object literal containing the current request count and timestamp of the beginning of the current slot. Within the middleware function, for each incoming request, let's save the client's IP's address and calculate the start time of the current fixed window slot. Let's now find the store's entry corresponding to the client's IP address, and if no entry exists yet for this time slot, let's initialize the request count to 0 and save the timestamp of the current slot. Let's now increment the request counter and either reject the request by responding with an HTTP 429 if the request count exceeds the allowed limit for this window, or forward the request to the next middleware using the next handler. To test our implementation, let's include the number of seconds the client should wait before making a new request through the retry after header of the response every time the limit is exceeded. Let's import this module into the simple server module I've previously created, mount it to the existing get route, and initialize it by setting the limit to 1 request every 5,000 milliseconds, which is equivalent to 5 seconds. Let's now start the server, and in a second terminal window, let's send the following request twice in a row, which, as you can see, causes the server to first respond with an HTTP 200, followed by an HTTP 429, indicating that the request limit is exceeded and that the user should wait for 4 seconds before sending a new one. The sliding window strategy consists in looking back over the last n seconds or milliseconds from right now and counting how many requests a client makes within that rolling window. Once the client exceeds the defined maximum amount of requests in that rolling period, all further requests are blocked until enough time has passed for all the requests to fall outside of the window. Note that, unlike the fixed window, the sliding window strategy prevents boundary burst exploits and matches the natural meaning of n requests per window, but uses slightly more memory and computing operations. This is why this strategy is often used for public APIs. So within a file named slidingwindow.js, let's declare a new function named slidingWindow that takes as parameters the maximum amount of requests a client can make, the duration in milliseconds of the rolling window, and returns an Express middleware. Let's also export this function for later use, and let's use a map object once again to create an in-memory store for tracking the number of requests made by clients, where each key will be the client's IP address, and each value will be an array of timestamps corresponding to the timestamp of each request made by the client. Within the middleware function, for each incoming request, let's save the client's IP address and the current timestamp. Let's then retrieve the list of timestamps of all the requests made by the client and update the in-memory store with an empty array if the list is empty to ensure that the store has at least one entry matching the specified key. Let's compute the oldest timestamp in the current rolling window, filter out all the timestamps that are older than the beginning of the rolling window, and save the prune list back to the store. Let's now either reject the request by responding with an HTTP 429 if the number of timestamps exceed the allowed limit for this window, or add the current timestamp to the list and forward the request to the next middleware. To test our implementation, let's include the number of seconds the client should wait before making a new request through the retry after header of the response every time the limit is exceeded. Let's now import this module into the server module and mount it to the existing GET route using the same parameters as previously. Let's restart the server, and within a second terminal window, let's send the following request twice in a row, which, as you can see, causes the server to first respond with an HTTP 200, followed by an HTTP 429, indicating that the request limit is exceeded. The token bucket strategy consists in assigning each client a bucket that fills with tokens at a steady rate over time, for example, 10 tokens per second. Each request the client makes consumes one token from the bucket, and if the bucket has tokens available, the request is allowed. Otherwise, the request is blocked until new tokens are added. Note that, unlike the two other strategies, this one offers the best balance of fairness and flexibility, supports controlled bursts, but requires a bit more logic to implement and maintain. However, this strategy can be used for all types of endpoints as it combines steady rates with short bursts. So within a new file named tokenbucket.js, let's declare a new function that takes as parameter the number of tokens to refill, the refill rate in milliseconds, the maximum amount of tokens a bucket can hold, and returns an Express middleware. Let's use the map object once again to create an in-memory store for tracking the numbers of requests made by clients, where each key will be the client's IP address and each value will be an object containing the amount of tokens left in a bucket and the timestamp of the last refill. Within the middleware function, for each incoming request, let's save the client's IP address and the current timestamp. Let's retrieve the bucket corresponding to the client's IP address and create it if it doesn't exist by setting its initial amount of tokens to the value of the burst argument and the timestamp of the last refill to now. Let's calculate the number of intervals elapsed between now and the last refill, and if at least one full interval elapsed, let's either fill the bucket to capacity or refill it with the number of tokens multiplied by the number of past intervals. Finally, let's either reject the request if there are no more tokens in the bucket, or decrement the amount of tokens by 1 and forward the request to the next middleware. To test our implementation, let's include the number of seconds the client should wait before making a new request through the retry after header of the response every time the limit is exceeded. Let's import this module into the server module, mount it to the existing GET route, and define a refill rate of 1 token every 5 seconds with a maximum bucket size of 3 tokens. Let's restart the server one last time, and within a second terminal window, let's send the following request 4 times in a row, which as you can see causes the server to first respond with 3 HTTP 200s, followed by an HTTP 429 indicating that there are no more tokens in the bucket. And here it is for today, guys. If this video clicked for you, don't forget to hit the like and subscribe buttons, as it will really help me grow this channel. And if you're ready to go pro with backend development, check out the Learn Backend Mastery program, your 0 to higher roadmap to become a job-ready Node.js backend developer in only 12 months. The link is in the description below. Thank you for watching and see you in the next one. Cheers.